All right, let's see how this working here now. Again, this feedback again. Give me 1 second there, will you? How do I mute this thing, right? Anyway, that should work. I pause it, right? So that shouldn't really affect, right? So let me blaze through. Let's see how this looked. Let me see if I could do out most of this, huh? Right. So what we had basic little fractions, basic little square rootings, a little compound. Ooh, they give you the formula. Probably remember seeing this in the summary.
No.
To borrow my summary. This exact formula in the summary. Anyway, it's just to use it. Nice little simplification here. Ooh, tricky little simplification. Ooh, what should I give you here? They give you a little quadratic to get some shapes here to describe. Right? Little coordinate geometry there. Basic little stats. Practicing your little means. See, good thing you practice one of that. I feel like I do one of this, you know.
So if you know how this question gave me real trouble, the last two parts.
When did I do this in class? Did I do it with this class, boy? In the all-nighter?
I think so.
Yeah, but it took me forever.
I think I do the exact thing in the...
And I didn't get it.
Okay, I'll check it out. That's all. Yeah, the critical thinking question. For functions, come here. Right, just like the one that we do in class with the sketching. Wait, look at this. Easy.
See, and you should see the other one. I was so hoping that easy circle theorem question come because that is my least favorite. And
you have angular elevation, long, right? Little matrix multiplication. No transformation. Okay, no transformation matrices. That was good. And then you have your vectors looking nice, man. All right, not so bad down in the back. So let's check out down in the front here, right? Right, so by rounding each number in the expression below to one significant figure, by rounding each number in the expression below, right? Passing a little tricky thing there already. To one significant figure, estimate the value, right? So square root of 108. So I feel I want you to give you a little bit of working. So to one significant figure, this will be 10. Hold on. This will be, let me write in red. This will be 10. Right? 19.72. So one significant figure, this will be 20. That's the problem. When I write it on the paper, not all the numbers will show up properly. And then 5.296 to one significant figure is 5. So that's 10 over 25. Right? If you simplify that, that'll be what? 215, or you could write it as 0.4. Right? So that's kind of what they wanted. They wanted, right? Round off each number in the expression below to one significant figure. Okay, so that could work. Then they said, find the exact value of this using your answer as a mix. They didn't say calculator, so most likely they want you to work it out, right? Right, so that's 3 by 8, that's 24 plus 3, that's 27 on 8. Some things mightn't show up here. I feel I might have to write it over somewhere. Anyway, let's see how to work out the LCM here. You can leave it as 12 or you can leave it as 36. Anyone will work out. So just simplify it, right? So here will be 5 and here will be what, 4? So that'll be 27 on 8 multiplied by 12 over 9. We can simplify this. 3 into this 3, 3 into this 9, 4 into this 2, right? 4 into this 3. Those 3 will cancel, so you get 9 on 2. Represent your answer as a mixed fraction in simplest form. 9 on 2, right? Right, so you have your 9 on 2 there. If you have any questions, or like stop, man. Right, due to COVID-19 pandemic, the number of available seats in the hall was reduced from 125 to 93. Calculate the percentage decrease. So they want the percentage. They want the. All right, I can't write all the words, right? But they want the percentage decrease. So the original value is 125, and that will be the decrease is 125 minus 93 by 100, right? And that will give you the percentage. So that's 125 minus 93, and you divide that by 125, right? And when you work it out, I got 25.6%. You might remember what exact values you got, right? But you might have an idea. So it's 25.6. Okay, next little part. Right, Micah invests a certain amount of money in a bank that pays compound interest at a rate of 2.5%. So we appear to have the rate here at a time for 2 years. So we have time here, right? Or in this case, is N. The value of her investment is $7,564.50. So that appears to be a principal. Calculate the amount Micah invests. Okay, wait, just now. The amount of her investment, where A is the amount of years, A is equal to the total amount after N years. Okay, well, this appears to be her A. Right? Calculate the amount Micah invests. So she invests a certain amount, so that's what they want to get the principal. Right? So we can make principal the subject one time, right? Or you could work it out and then put it across. It's up to you. I would just make principal the subject one time. So that's A over 1 plus R over 100 all to the power of N. You don't have to do that. You can just plug in the values, right? And then make P the subject. So the amount that she got was 7564.5 all over 1 plus R. R was 2.5%, right? So R is 2.5 over 100. That's 2.5% by N. N is at the end of 2 years. Okay. Right. The beautiful thing about the Casio is that we could just plug this in, right? 7564.5 all over, open brackets, 1 plus 2.5 all over 100 squared, right? And I got 7,200, right? So that appears to be Micah's investment. Okay? Are you okay with that?
Yes, sir.
Yeah, well, too late now. If you're not okay with it, it might be kind of too late. All right? But hopefully you can get out. It was a little tricky with the wording, huh? The wording was a little tricky. Some people might get catch with that. We had to simplify this, so we multiplying the 3 and the 2 and the 3, you'll get 6. And then with the y, same base, right? Actually, I'm gonna show you the working. So that's 3 multiplied by 2. Here, you're dividing, so you're gonna subtract. So that'll be 8 minus 5. So y is equal to 13. Then they want you to factorize here. So you could see that they both have y in common. So you'll get x minus y. Then next one is difference of 2 squares. So it's x minus y by x plus y. I like how they say hence here. So you know something. You have to use the part on top, right? Then you have right? Then you have x minus y, x plus y. The x minus y's will cancel, and you'll get y over x plus y. Right? Nice. How much marks was that? 1 mark in the last. Anyway, they kind of break it up for you. So you get 3 marks. Next part. Question said the diagram below has 2 rectangles. They give you the dimensions. Given that the difference between the areas is 64, show that that is up. So we could set it up one time. We could say that the area of M minus the area of N is equal to 64, right? M looking much larger, right? So how you get area? You're going to multiply the length by the width, right? That's for M, and you're going to multiply the same thing for N. That'll be x plus 2 by x minus 3, right? You have to make sure and expand it out properly. Here you will get 3x squared minus 9x plus 4x minus 12 minus, right? I put in a bracket here because I don't want to get the signs in here wrong. So that'll be x squared minus 3x plus 2x minus 6. And I bring it across the minus 64 because if you look at the answer, it's equal to 0, right? So what we will get now, 3x squared minus 5x minus 12 minus x squared. Inside is minus 3x plus 2, so that's minus x, but there's a minus on the outside. That becomes plus x. Minus by minus 6, that's plus 6. Minus 64 is 0. Right, that bracket here, see this bracket here? This bracket is important. You want to make sure you expand it out properly, right? So now we can bring the x squareds together, run out of space. So I'm just going to work out that 3x squared minus x squared, that's 2x squared, minus 5x plus x is minus 4x, minus 12 plus 6 is minus 6, minus 6 minus 64 is minus 70. But that is not the answer. So we had to divide by 2. You'll get x squared minus 2x minus 35 is 0. Right? A little bit of working and expansion. The beauty of questions like this is that you see the answer, you know what the answer is, you know what you're working towards. So if you do get minus 35 or you're minus 2x, then check back fast the expansion if you made a mistake. Right? Good. So that is your number 2 part C. Let's continue. Number 3, the diagram below gives 3 equilaterals, P, Q, R on the same grid. Q and R are images of P. Q, where is Q? Q and R are images of P. So Q definitely looking larger than P, so that's an enlargement. P looking like a possible rotation. It's not a reflection, it's not a translation. So it's probably a rotation about some point. So let's see. On the grid below, draw the image of the equilateral P after translation 10 minus 4 and reflect in the line y is 0. So 10 minus 4 and then in the x-axis. Oh, by the way, I hope you all remember that this is the x-axis, y is 0. All right, so let's slide it first. 10 minus 4. And so that is to the right 10 and down minus 4, right? To the right 10. Oh gosh. Let us see what we will do. So I'll count it for now, right? I wouldn't write it out and then work. I just can't count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then down 4. 1, 2, 3, 4. Right? So that's the top of it. Then it will go down here. It will go down here. Then it will go down 2. Right? So that's P prime. Right? So I did it for each point. What you could do just to be sure, you could write out the point like -7. That point there is -7, 7. And then add it to 10 minus 4. And you'll end up with 3, 3. Right? That's where I ended up there. And then do all the others, right? So that's a P prime. And then they want you to get P double prime. So you're going to reflect in the, you're going to reflect in the X axis because Y is 0 here. Right? And you're going to reflect it. Remember, when you're reflecting, if you reflect 3, 3, the X value stays the same, but the Y value becomes -3. Right? So that'll be right here, right here, right here. And this point stays the same, right? So the diagram underneath is your P double prime. Okay? So that is your second part there. First and second part both together, right? Remember you all know how to write this, yeah? Well, I know you all know, you just look back at the video, right? Right. Describe a single transformation that maps P onto Q. Where is P and where is Q? Right. How we mapping P onto Q? We can see it an enlargement, right? So we can see definitely the scale factor. The length of this line here is 1 across there. This is 1, 2, 3. So it's a scale factor of 3. So you can measure the lengths and work it out, right? Same thing here. Here is 2. Here is 2, 4, 6. Right? So we know about the scale factor. That's the easiest part. And it's positive because it appears to be on the same side, right? Now we need to get the center. So we're going to do the little lines thing here, connect up the line to the image. Let's see if we can figure out. I can kind of see the little cheat line there. Right? Do a few, right? It'll be a nice point. CSEC will give you a nice point. 3 is enough to confirm, right? So you're getting what there? You're looking like, quite down there, boy. -11, 8. You're seeing that? So to fully describe it, it's an enlargement by a scale factor of +3 about the center -11, 8. Right? Right? Next one now. So here's what we need to get. Firstly, we need to find a way to get the center of rotation, right? So let's connect some points here. Let's connect this point and this point, right? Let us connect which 2 points again? Let's connect here and here. We're collecting the point on this image, right? Right, and right, right, let me change the colors. Hold on, I will use red, right? So we have to connect and then we have to bisect, right? How am I bisecting this way? All right, well, I gotta try a thing, right? I really don't know. Let me just average. 1. All right, this one will be tricky for me to do. I just average in me. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4. It's supposed to be perpendicular as well. All right, I'm gonna just change the color of the line. Let's just do here. Do the points that you show are images of the other, right? Right, where those two bisected lines meet, that was supposed to be a center. Right, so it might be somewhere there. When y'all did it, you remember which side it was on? So it might have been there. This is one I may have to redo, right? I might have to redo this and see. And then if you connect it, if I connect it, again, it's not perfect. That's the problem. If I connect here to here and here to here, I'm seeing that it's a close to 90 degrees in a clockwise direction. So it might be a clockwise rotation, 90 degrees about some point. Maybe the point is here. Maybe the point is here. It's looking like that to try to be equidistant and thing. Okay, so I'll have to do that one. I can't do that one here. I'll have to do the exact thing and I'll send the answer. Not anti. Well, it going this way from what I'm saying here. If you say anti, then you might have to say 270. So it looked like it went clockwise, although it looking more anti-clockwise for truth. If I look at it looking more anti-clockwise, but I'll have to ignore that one because I feel like I'm doing something more there. I'll have to use the lines properly. Because if you look at it, it looks anti. It looks like it went anti-90. But I would check it. I don't want to tell you the wrong thing. I don't say I do craziness there with that line, right? So I'll fix that. Sorry about that. Right, let's come back here. What is the intercepts? Right, the intercepts here. The intercept of line L, that's where it cuts the y, cuts the x-intercept, right? So they want the x-intercept of line L, so that's 6, right? Give them the point, 6, 0. And the y-intercept of line M is right down here. That's 0, minus 2. Okay, those are the intercepts. Nice. The equation of line L is that find the value of the point K, right? So you have x plus 2y minus 6 is 0. They want you to find K. So they give you the x value, but they didn't give you the y value. So just plug in the x value. 9 plus 2k minus 6 is 0. So 2k plus 3 is 0. K is equal to, when you carry across the 3, you'll get 2k is negative 3. So k is negative 3 on 2. Right? Yeah, basic, Dimitri, basic. Find the equation of the line M in the form y is mx plus c. I think I forgot the line. Hold on, I'll go back and get it, right? The line M, actually I have to do it right here. Which one is M? This one is M, right? The y-intercept C, that's minus 2. I just need to get the gradient, right? So I could pick any two easy little random points and I could plot it, right? I'll pick here. I'll pick 1, 0. Or you could use the rise over run. 0 minus 2. So it's minus 2 minus 0, 1. Sorry. Minus 2 minus 0, right? 0 minus 1. So I am getting 2 as a gradient. So the equation is the equation of M. The equation of M is y is equal to 2x minus 2. Right? I had to do it here. I can do it on the next side, right? Right? So here, y was equal to 2x minus 2. Show by calculation that the line L and M are perpendicular. So what's the rule for perpendicular? Perpendicular, when you multiply both gradients, you get minus 1. That's the rule, right? The product of two gradients is minus 1. So let us see if we could find the gradient of L now, right? So L was x plus 2y minus 6 is 0. So that means 2y is equal to minus x plus 6. Divide everything by 2, you'll get y is equal to minus a half x plus 3. So therefore, the gradient of L is negative a half, and the gradient of M is 2. Negative a half by 2 is negative 1. So therefore, perpendicular. Okay? The line L and M represents the graph of a pair of simultaneous. Using the graph on 11, write down this solution. So all we have to do to write down this solution is just read it off, right where they intersect, right? And that point is 2, 2. So the solution is 2, 2. Right? Might people looking okay so far. Right? Next, they give you some stats here. They give you a cumulative frequency, usual shape. Using the determine the number of students who took more than 50 minutes to solve, right? So we have 200 people in all, right? More than 50, whereas 50 is here. So we come up here and we read that top. That looking like every small dot is what? Every small dot is about 4. Yeah, about 4. So that is 188. It went, hold on, looking like 196. So it's at about 4 people. So that's 196, right? So people who took more than 4, that's between 50 and 60 basically. That's about 200 minus 196, which is 4 people. The median time taken, well, this is the total. Median is the total divided by 2, which is 100. So, whew, I'm gonna just zoom up there a little bit. Right, so that's 100. Read that value of, I would say it kind of middle-ish and all, yeah. Kind of middle-ish. Right? So it's in the middle of those two blocks. So this is 34, 38, 42. So it's in the middle of 42 and 46. So I'll say 44. Right? Oh wait, no, sorry, wrong scale. My bad. Sorry, yeah, wrong scale. So that's 31, 32, 33, 33.5. Is in the middle, right? So I would say that the median here is 33.5 minutes. Right, I was watching the wrong scale. I like how this thing writing, huh? Anyway, I'm gonna make somebody write over this summer because I do the video. So that is 33.5 minutes. Some lucky person will get to write over this nice summer. Right, so nice. That was number 5. Oh no, we're not done. Part 3. The probability that the student has at most 28, right? At most 28 means it has to be 28 or less, right? So 28 is like right here. Yeah, that looks like 28, and when it come across, looking like 64. So you have a total of 64 out of 200, right? So 64 out of 200, right? Or you could say 32 on 100 as a probability. Or you could even say it's 0.32. Right, 0.32 appears to be the probability there. Right, let me just make sure. That's making sure they only read off that good. 28. I want nobody message me and tell them I write down the wrong thing. 22, 28, and I'm going up there. Yeah, man, I'm looking like 664. Yeah, looking like 664, right? So I'll take 64. Nice. Let's check out this here. right? Using the cumulative frequency curve on page 33, I want you to finish off this. So this is real nice. Don't you have me flipping between these things? Real nice, real nice. So 11 to 20. What value was that? And the pointed thing in the middle too. All right, guess now, yeah. So it's for 20. 20 is a cumulative and 50 cumulative. All right, let's just see. 20. Looking like it's in the middle. 22. Middle of 32 and 36. So I would say 34 is that cumulative value. And then 50, come on 50, come on 50, be a nice value. 50, 50, 50, 50 and so bad, 50 and so bad. Oh, we did 50 earlier, that was 96. All right, so let's go back to the table and see if we could fix it up now. Right, so the reading was 34, so that would be 12 minus 34, which is 20, which is 22, right? And then 96 was this value, so that would be 84, 96 minus 84, which is 6 and 6, 12. All right. Just checking it back, adding it all back up, just to make sure that we get 200. $12 plus 22 plus 42 plus 84. $176. Right, I'm gonna just check it back again, right? So this value is 34 minus, that value is 34 minus 12, right? So that value, correct, that's 22. When it was 50, it is, oh, 196, yeah. I write down the wrong thing. Right, again, so you see what I did there, right? I was able to check back and make sure, right? Right, so I was able to check back and make sure that that it works out. Right, anyway, so that will be 196 minus all the values on top of it, right? So that will be 196 minus 84 minus 42 minus 22 minus 12. So that's 36. Right, so again, I'm going to check it back and make sure it sums to 200, right? I don't want to get it wrong. So 12 plus 22 plus 42 plus 84 plus 36 plus 4. Nice, 200. So I'm good to go. Right, so that little check is important to make sure we get the right values, right? Because a common mistake might have been just to subtract the value from 84, right? Which I think I did in the beginning. Right, so I'll make a little small mistake there. Right, but the check to make sure you get it right is that when you sum the frequency, you get 200. All right, let's find f of x. So that's 15.5 multiplied by 22. So that's 341. And then 36 by 45.5. Then 36 by 45.5. I have 1638. Right, now I need to get the sum of fx. So adding that to 222 plus 2982 plus 1071 plus 341 plus 66. So I have 6320. So they want us to find the estimated average. So that's the mean. So that's the sum of f of x. For group data, this is the formula. So that'll be 6320 all over 200. So you divide them by 200. Right? How you will know if this is wrong is if you get a value here that's not within these limits here. So if you get something outside of 1 and 60, then something wrong. So the mean appears to be 31.6 minutes. That's it. Yeah, all okay with that? Anybody remember? Anybody remember again that value? Right? Don't get, yeah. Sure. But you don't remember anything? Something. So yeah. Don't worry. At worst, you pick up some marks for formula, and you probably lose a little 1 in between, right? But your working should be good. Right now I'm freezing up here, real cool boy. My neighborhood is cool, huh? Come back home. Right, so you have that there, you have that there. Right, now the question that Azaria do like. Right, show that it is I need you to redo the sequencing. Well, yeah, I need to know sequencing. No, I was gonna try to avoid that. This one, number 7. I was gonna run from that. I'll do it. Yeah, I'll do it. It looking like a normal one. I ain't seen any major errors and things as yet. Looking good. Right, so show that the length is 350. It's a beautiful question. They tell you what to get. The length of the running track. So the diagram below shows, so we're trying to get the total length, right? The diagram below shows a scale drawing of a running track. It consists of a rectangle and 2 semicircles with diameters 49 as shown there, right? LN and right, nice. LM, right, 98. So we'll put some readings here. Here's 98. Here's a semicircle, right? So that's 2 pi r divided by 2, right? Or you could say since they gave us diameter, let's use pi by d over 2. Same thing here. Pi by d over 2. So we had to add up all of that, right? So the total length will be 98 plus 98 plus 2 by the 2 pi d on 2. So that 2 cancel, right? So so let's try to add it. But by the way, they told us what pi is, right? Right, so let's start here. 98 plus 98, that's around what, 196. Multiply by pi. Pi is 22 over 7 and this is 49. So this is 196 plus, as a plus sign, right? Looking like a multiplied. Plus 7 to 49 is 7. Yeah. So that's 22 by 7 that I have to add to, right? So that's about what? 154 when I add it there, 200, 350 meters. Nice little fella there. 2 marks, easy. Easy 2 marks there, Azaria. Easy. She was complaining of Justin. He says, sir, I think we'll have. All right. So you get through. Nathan works at a constant rate of 1.4. Calculate this time. Calculate the time it will take him to make 7 laps around the track, right? What was it? The length again? The length was 350 meters. Time, we know speed is distance over time. So time is distance over speed. Distance is 350. Speed is 1.4. So calculate the time to walk 7 laps, right? This is 1 lap. This is 1 lap. So that's 350 divided by 1.4. I have 250 seconds. So for 7 laps, it would be 250 multiplied by 7. But he asked the answer for it. They didn't specify, right? So I leave it like this, 1750 seconds. I'll get any pen while I here. 1750 seconds, right? Right, can I leave this right here? Yeah, should be able to work it out, right? Right, so Tafari runs 1 lap of the track in 68. What? Tafari is a cheater. Go fast. Oh, that's run. Okay. Nathan walking, right? So determine the number of laps Safari can complete in 1 hour running at the same speed. Running at what speed? His speed, right? So let's find his speed. Speed is distance on time. So the distance is 350 divided by 68. Right, so that's 350 divided by 68. So that is around 5.15 meters per second, right? So that's his speed. And let's find the distance that you will be able to cover, which is speed by time in what, 1 hour, they said? So that's 5.15 multiplied by 1 hour, which is 60 minutes by 60 seconds. So that's 5.15 by 3600. So that is 18,540. And then we're going to divide that by 350. So we'll know the number of laps. So divide that by 350. Oh boy, Kagema, nice number. How many laps you'll be able to complete? It's saying 52.97. Right? So that means you'll be able to complete 52 laps. Since they insist on giving it like that. Hold on, Let me just see if I didn't round off, right? So 350 divided by 68. That's the exact value, right? And I multiply that by 3600. And then I divide that by 350. Still getting 52.9 something. So he is able to complete 52 laps. He is close to the next one, right? Based on their wording, we get him write both answers, right? 52.97 and then say, well, approximately 52 laps. Let them take whatever they expected. Nathan completes running one lap of the track every, wait, Nathan running now, right? Nathan completes running one lap of the track every 72 seconds. Tafari and Nathan start running at the same time from point L on the track. Did they show us point L? Okay, yeah, so it'll start at L. So we know what L is. Hold on there, trying to get it back. Right. So Tafari and Nathan start running at the same time from L on the track. Each completed a number of laps on the track, right? So that means Tafari going at his speed, right? This is Tafari's speed. I just read it out first. Tafari and Nathan start running at the same time from point L. Each completed a number of laps on the track. Calculate the least number of laps that each will complete before they are both at point L again at the same time. So it means that, right, so it means that we have to get the new speeds, right? So let me write this one in black here. So Tafari's speed is 515 meters per second, right? He takes 68 minutes. He takes 68 seconds, sorry, for one lap. Nathan takes 72. So we could get the multiples. Hold on. I'm gonna just get Nathan's speed. Mightn't even need it, but I'm still doing it. Nathan's speed is 72 seconds. So that'll be 350 divided by 72. So Nathan's speed is 4.86 meters per second, right? That's Nathan's speed, right? Okay, nice. So good. So we have their speeds, and here's what they want. They want the least number of laps that each will complete before they are both at L again at the same time. So they want the time taken at those speeds to cover equal distances. So basically, the distance that they're both going to cover, distance speed by time, has to be the same, right? So the distance for Tafari will be his speed, 5.15 by the time, and the Nathan's speed, right? Nathan's speed is 4.86 by the time, because they have to cover the same distance. So for those t's to be equal, that's not again 0. That's not. Let me see if I can set up two equations and solve it, right? All right, let's try it like this instead. Right, because it's 2 different times, right? It's 2 different times. All right, so we just see in here that Nathan is 4 seconds slower. So, right, so every time we complete one, it'll be 4 seconds behind. Yeah, it's a little tricky, but I'll try to set up 2 equations there. So Nathan is 4 seconds behind, right? So 72 divided by 4 is how much? 72 divided by 4 is 18. Right? 72 divided by 4 is 18. So by the time a boy Tafari makes 18 laps, right? So by the time the least number of laps each will complete. Right? So Tafari complete 18 more laps. I just want to make sure I'm stating it right. Then they will meet back at the same point. So Nathan completes right? So it appears that 18. All right, I've had to solve this a different way, right? But it takes 18 more laps after that. So 4 seconds behind. So Tafari completes 18 laps. And then Nathan only completes 17 laps. All right, I'll find an easier way to work it out. But basically, Nathan's slower by 4 seconds, right? So every time Tafari completes a lap, Nathan 4 seconds behind, basically, right? So by time Tafari completes 18 laps, Nathan now completed his 17th lap, right? So it appears that Tafari will complete 18 and Nathan will complete 17, right? I will check it backwards and I'll work it out just to make sure. let's see now. Let's check and see if the times will be the same. So these equations here are supposed to hold, right? So time is equal to distance covered, which is 18 laps by 350 all over the speed. That was it's Tafari, right? Tafari is 5.15. So it's 18 by 350 divided by 5.15. So that time is 1223.3. Let's check out Nathan now. He did 17 laps by 350 all over his speed, which is 4.86. So that's 17 by 350 divided by 4.86, which is close, kind of close. 1224.3, right? Which is fairly close. Maybe we do a little rounding off in between. So that's basically how much seconds between. That's how much seconds between it, right? Are you okay with that? So one is 1723, one is, wait, that's 1223, yeah, that's 1223.3 and 1224.3, right? So that pairs the time. I will set it up a little bit nicer, right? I just do it kind of raw here, right? So I was trying to get two equations that we solve simultaneously. But that's basically kind of how you could do it. Justin, you got that? Very good. All right, so that's one way you could do it. All right. So I will set it back up and I will do that a nicer solution. It will look like that. Right, but all you did, right, there's 3 marks, right? So you may have written Nathan's speed, Tafarel's speed, and you may have seen something like this. So within that 3, you might be able to scrape in a 1 or a 2, right? But it was a little challenging, right? It was a little bit challenging, right? I initially thought that, yeah, you could have jumped into these 2 equations and solve them simultaneously, right? But I will set it up via simultaneous and we'll solve. Okay, but that's a nice little question to pop in there and make it think. But of course, it's 3 marks, right, told you. So after 3 minutes, you're not getting it out, stop and move on. All right. If you have time to add up, you could come back and do it. All right. So the grid below. All right, next one here, they want the next figure. Well, here now, right? So they want the next figure. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5 is that figure, right? So 6, 1, 2, 3, 4, 5, 6. How much are you going up? 4, 1, 2, 3. Oh, it's a square, right? Right. So we want the figure. They want the figure going up, right? What we have to do, the grid below, 3 figures. Each figure is made up of using a small squares of unit length that are both colored and shaded white. Oh, I'm not seeing that. Some shaded and some not shaded. All right. So 1, 2, 3, 4, 5, 6. All right. So I will try to circle the ones that have to get shaded. Right. So we shade in here. We shade in here, we shade in here, we shade in here, we shade in here, we shade in here. Right? And then we shade in based on what I see in there, we shade in the top. Is a kind of 7 thing, looking like a 7. Right? So it's looking something like that, right? Yeah. So it's like that, both colored and shaded. Okay, now let's go to the table. Somebody said they didn't like this. I mean, if it's an AdMath person, APs and GPs should jump out there, right? Right, good. So let's check it out. I like to get the formula and the pattern first. So I'm gonna get the pattern here first. 1, 2, 3, whatever on the outside is here. So that's 11. There's 2 staying the same, right? So it's 11 plus 2 squared, right? So 5, 7, 9, right? So I get the whole thing wrong, I sure. No, just follow the pattern. It can't be so difficult, right? So that's 5, 7, 9. So basically each value here increasing by 2, right? Right, and then you have your first term as 5, right? So I showed you all this formula. First term 5 plus the number of terms. So it's n minus 1. In this case, is 11 terms. Minus 1 by the common difference is 2, right? So it will be 5 plus n minus 1 by 2. Or you could say 2n plus 3, right? 2n plus 3, right? Nice. So the one on top here was how much? 10 by 2, 20. So that's 25. We get that out. This 52 came from where? Oh, after square this here, sorry. 11, that's 13 squared, right? That's about 169, I think. Yeah, 169. Right? Next one is the perimeter. So it's 12 for what? They all increasing by 4. They all increasing by 4. So the first value is 12. Then you have n minus 1 by 4. Right? Nice. So here is how much? Here is 23. So here is 23. Here will be 12 plus 23 minus 1 by 4. Right? So that's 22 by 4 plus 12. Right? I got 100 here. And the formula here, as I said, was n plus 2 all squared. How many white squares in figure 11? Well, you just count it, right? Are you okay with that? Let's check out the next one. How many white squares in figure 11? Where is figure 11? Did I rub it off? How many white squares? All right, so that's not right. I'm gonna just write it back. I forgot what I had. So was it 25, right? So the total number of squares was 169, and then you just minus out colored. Right? So that's 169 minus 25. So that's 144. All right. Next one. Simplest form. The one g of x minus g of 2. So that will be x minus 2 squared minus 5. So that's x squared minus 4x plus 4 minus 5. So that's x squared minus 4x minus 1. F inverse 11. So let's find f inverse first. F of x is what? 4x minus 1. So do all these steps and you'll get f inverse x is x plus 1 over 4. So f inverse 11 is 12 on 4, which is 3. Then they want h of 1. The best thing to do is to find h of 1 first. H of 1 will be 3 to the power of 1, which is 3. So then we're going to find h of 3, which is 3 to the power of 3, which is 27. Nice. Nice job, Clarissa. You get full marks there. Nice. So that is that. H of 1. We are doing catching here. right? So x is minus 2. So what's that? That's 4 plus 2, which is 6 minus 2, which is 4. 0 will give us minus 2, right? Your calculator did it for you. Okay, nice. So you plug it in using a scale of 2. Nah, I'm not serious. I'll set up this whole scale. There's a minimum, right? 2 centimeters to 1, right? So that's 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So let's plot it quick. Minus 2, 4. 1, 2, 3, 4. So that's all the way here. Minus 1, 0. So that's quite back here. When it's 0 is minus 2. So it right back down here. 2 is 0. Sorry, 1 is minus 2. Wait. When x is 0, right, that's minus 2. 1 is minus 2. Both is the same, right? And then 2 is 0. And then 3 going all the way back up to 4. So I'm going to connect it up here. Right, somewhere in the middle there might be the turning point. Okay. So it might look something like that. That's it. That's all they want. Very easy marks, man. They're down. And number 8 is a mashup, man. Nice. Number 9. Right, it's looking real nice. Right angle. We could figure out here because here's 90. So right, use appropriate theorem. State 3 reasons why the measure of angle is Z is 45. So that's 45. 3 reasons. Reason 1 is that WUV is 90 degrees, right? WUV is 90 degrees and WXU, yeah, that's 90 degrees as well, right? And therefore, WXU is isosceles, right? Probably spell it wrong, but it's isosceles, right? So once here is 90, it means that here is 45 and here is 45. So it means that here is 90 minus 45, which is 45, right? So that's it. You use the appropriate theorems there and you work it out, right? Or here we could also do. Yeah, you have a few options, right? Next thing you could do is say here and here equal, right? Tangents of a triangle, those interior angles, they're equal. So you know here is Z and here is Z, and therefore here is 90. So you could say 2Z is 90, and then Z is 45. So you have a few options, right? I don't want to be wrong here, but was that probably the easiest one? Out of all that we do that all night and all before, I think that's one of the easiest ones. They tell you the answer to. The diagram below shows a circle with diameter KF. You know, they got blaze all in June. The diagram below shows a circle with diameter KF. Right, I've seen it, good. And the line, we just had to get X and Y, right? So I'll just do it right here one time. And I'll just say the answers, right? The points F, H, and K, and J lie on the circumference, nice. So they want us to get X first, right? So we know that one chord forming 2 triangles, angle at the circumference equal. So X is 54, right? What else? They want us to get Y, right? 56, thanks, 56. 56, nice. So X is 56. Then they want us to get Y. We have a few options. Option number 1, this is 56. So we could work out there right? Remember, that will be 180 minus 56 minus 19. So that angle there is 105. So it means that y is 180 minus 105.
75 actually.
So y is 75, right? Y is 75. To me, that's one of the easiest things that we could do there to get y, right? So y is 75. Nice. So that is that. The diagram below shows 4 points, P, Q, R, and S on level ground, where pillars will be placed to mark the outline for a foundation. P, Q, R, S, whereas P, Q, R, S on the same ground, right? Where pillars will be marked, right? The vertical posts, there is a vertical post RT at R. So there's a vertical post here, RT at R. From Q, the angle of elevation from Q right? Remember, there's a flat ground, right? From Q, the angle of elevation of the top of the post is 21 degrees, right? So remember now, it's all as flat ground, and this pole up in the air, right? So the angle between Q, R, and T, right? The top here is T, that angle is 90 degrees. So you have a right angle triangle there, and you have adjacent, and they want you to find opposite. So you're using tan. Tan theta is opposite over adjacent. So opposite is equal to adjacent by tan theta. So adjacent is 153 tan 21. 153 tan 21. Right, so I get approximately 58.7, right? 58.7. What's the next part? Given that QS is 135, calculate the perimeter. Given that QS is anyway, I don't need that, right? QS is 135, they want the perimeter of the foundation. So here is 135. Sorry, 135. So they want us now to get this length here. So we have more lengths than angles and non-right angle triangles, so we're using cosine rule. So PS squared is equal to 83 squared plus 135 squared minus 2 by 83 by 135 cosine 29, right? So I square it in all at one time. 83 squared plus 135 squared minus 2 by 83 by 135. Make sure my calculator in degrees, right? Cosine 29. Ah, crap. Right, now I think I have it there. I got one time I got 74, right? 74.3 meters. So the perimeter, I'll do it right here. The perimeter is 153 plus 110 plus 83 plus 74.3. So it's 153 plus 110 plus 83 plus 74.3. Right, so that's equal to 420.3. Right, so you might, I guess, something close to that, right? Anybody remember that value? If I get something like that? Yeah, no, can't remember. Okay, my battery gonna die. I'll finish up this quick. Explain why this product is QS is not possible because it's not conformable, right? Right, which simply means the number of rows here, number of columns, sorry, number of columns of Q is not equal to number of rows of S, right? Basically 2 is not equal to 3. State the order of the matrix of SR. So when you multiply 3 by 2 by a 2 by 2, the answer is a 3 by 2, right? These two numbers are the same, so you end up with a 3 by 2. Right? Calculate Q by R. So that's 2 minus 143 by 16 minus 54. So that will be 2 minus 10. That's, oh gosh. That'll be 2 plus 5, 12 minus 4. 4 minus 15, 24 plus 12. So that's 7, 8 minus 11, 36. All right. You could always check back. When I do back the whole thing, I'll just check back my working just to make sure if I can make any little more small mistakes. Next one, they said the determinant is 5. So that means 4x minus 1 by minus 7 is 5. So 4x minus 7 is 5. 4x is 12. So that means that x is 3. Right? X is 3. Last part, they want PQ and they want, hold on, PQ, PR, RB. So they want PQ, PR, RB. All right. I am almost done. All right, let's check it out. So in the diagram, ORP straight lines, M is the midpoint, so I'm putting half and half here. Right, and OR, R is the midpoint of AB, so this is a half and this is a half. And here is 1/4, here is 3/4, right? Because it's split in a ratio 1 to 3. Then they said OP, O to P is 4A. So everything here is 4A. And OQ, everything here, O to Q, right? Everything there is 8B. So first thing first, PQ, real easy. P to O plus O to Q. And you ain't bound to do the rest. You could rock back because you get everything else right. And you ain't bound to stress yourself out for 2 marks. And so PO is minus 4A plus 8Q, 8B. And you're good to go. Finish your exam and relax. You don't go and stress yourself with PR and thing. Right, anyway, PR looking easy. So we have PQ already. PQ is minus 4A because they're going against the arrow and with, right, so that's positive, right? Now, they want PR. So PR is equal to 1/4, sorry, 3/4. 3/4 of PO, right? PO, not OP. So that's 3/4 of minus 4A. So that's negative 3A. And last part, they want RB. Where is RB? RB in the middle of this whole thing here. So RB is R to P, and I like the way they set it up for you, right? Because they make you find everything else you needed, right? RP plus PB, right? They kind of set up most of it already. RP will be positive 3A because we found PR, and then PB is 1/2 of negative 4A plus 8B because we found PQ earlier. And you're good to go. So that's 3A minus 2A, which is A. 3A minus 2A, which is A, plus 4B. Are we done? Finish our paper there. That's it. How long we took? I can't remember how long, no? 5 was very good, Justin. I'll do the paper 3 and next day, right? Okay, but that's it. That's basically it. From the whole paper, we can see the only stumbling block there. 2 stumbling blocks I saw. I saw the cumulative frequency when you have to read off the values to confirm the exact values, and that speed, distance, time question. I find that was a little tricky. Right? It's kind of like an odd math question. I remember from a graph and solving it, where they intersect. But I can do a time graph. A time graph is an option to solve it. Anyway, I want to cut off there. All my iPad going to cut off, right? So look at share with your friends. Share with your friends. Let them watch the link and check out the solutions, something if they want. All right. So that's it. You can log out. I will see you all during the week. All right. Bye.
Bye, sir.
Bye. 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 All right. Let me just stop.